Okay, thank you. Welcome to my talk about OPC UA. Some of you maybe have already been in the workshop that we did. Let's first talk a little bit about what we do, which is kind of important to understand the rest. I work at the company Danfoss at the location in Merano, basically Burgstall. There we have like 90 employees out of the 40,000 of the giant company. We have a team that's quite competent in creating drives. So we basically create motion drives, inverters that drive motors. And we use OPC UA there to test it, which I will elaborate more later. This is basically what we sell and offer. So we basically have PLCs over there, which is basically the controllers. And we will most talk about this part here. The thing that we then make is this and the drives, which is basically motors that you can then use to drive a robot, drive a belt, drive something. One of the applications, for example, is capping or labeling. So we are basically labeling, providing the drives that then spin the bottles to label them, to cap them, to basically put the caps on. So that's basically what we do. Let's talk about OPC UA. OPC UA is basically a standard and a suite of protocols that allows you to communicate to PLCs in a standardized manner, which is basically, it collects a lot of specifications. There is the legacy open platform communications, which is basically the OPC part. Those were like 40 or 50 different standards that were then all meshed together to create OPC UA, which is the unified architecture part. It's, as I said, it's a set of specifications that you use to communicate between devices. More importantly, it is basically OS and also language independent. The old specifications, the OPC specifications, were pretty Microsoft heavy, and they told that completely from OPC UA, and now it's basically completely operating system and language agnostic. We did the workshop, we had Linux, Windows, and microcomputers there, and they all were able to communicate with the drives or with the PLC, so that's quite nice. OPC UA is basically then just a bridge between a few layers. We see here a diagram of all those layers. We operate in this layer, which is incorrectly labeled, because it's not only sensors, it's also drives, it's also motors, it's actuators. And then there is the level 1, which is basically field level. That's where we find the PLCs, the programmable logic controllers. Those are responsible for taking all the sensor data and then doing stuff with that. Piloting some IOs, moving some motors, doing all random stuff. So it's a lot of things. And that's where OPC and OPC UA starts. It's basically where it allows you to interconnect these PLCs. Here you can see two PLCs of the same type, but PLCs from different vendors normally can't talk to each other. This whole industry stuff is pretty proprietary. Like, you don't have a natural way of communicating between PLCs. They lock you in, it's all locked down, which makes sense. But the OPC UA standard allows you to cross that barrier and to go beyond one PLC and talk to another, or even go upwards. You then have not just a PLC, you also have human interface devices, you have displays, you have computers that manage those PLCs. You want to control the machine from your PC, for example, like a lot of stuff wants to do. And it goes even higher, like it goes up to the enterprise level, which then also goes towards the cloud. Maybe you want to do something with the data that you have gathered on your PLC or on your sensors. That's what OPC UA basically allows you to do, and it basically helps you in that. It gives you that point, and it's also implemented by most PLC vendors, so you don't have to worry about, is it implemented on my PLC, is it not, does it support it, how does it support it? No, it's implemented by almost all, it's an open standard, and so it's basically ubiquitous. You can see it everywhere. And that is also, where the whole concept comes in. The whole OPC UA stuff is specified by the OPC Foundation, which is the open, the foundation that governs all of this. It's an industry consortium that's basically comprised of over 1,000 members. Like there's a lot of companies and big names behind that, and they all have the same goal. They want to interconnect their devices so that we can then have life easier for us. It was founded in 1949. They have like over 90 working groups where they specify different specifications. It starts from OPC, but we will then later also talk about some new specifications that they have on the horizon. And yeah, those 90 working groups specify like classes, how you interact with devices. They specify the whole communication stack. They specify everything. So it's all from them. So this is basically the head organization that then brings all of that together. One new thing that I want to talk a little bit today is OPC UA FX, which is basically OPC UA field exchange. As with the pyramid you saw, OPC UA basically starts at the controller level. Like it goes from there up normally. The field exchange specifications want to now lower that to the factory floor and even to the sensor level. Like they want to now net together the PLCs and also the sensors and all of that even closer, so that you can have OPC UA all the way down. So it now only goes to a certain extent, and they want to extend it all the way down. You can see that even here. They want, like this part here is already kind of, that's the OPC UA that we already works. Like you talk from a controller to a PC, or you can talk from a controller to another controller, which already works, but they want to go further. They want to say, okay, you can talk all the way down to the drive, you can talk all the way down to the sensor, to the output, which basically then allows you to also talk all the way up. That's their goal. They want to allow you from your sensor and maybe also your drive, which is interesting for us, to talk all the way to the cloud, which may be interesting. Maybe I want to ship off some data to the cloud. Maybe I want to know something about my sensor. Maybe I want to provide diagnostics, remote access, configuration, all of that could then be possible. As I said, this part already works, but it has a little problem. The normal OPC UA is not cyclic. So it's basically pretty indeterministic. You don't really have guarantee about when your data arrives. It's also kind of slow if you are talking about all the environments that are below. Like OPC UA, you're talking response times in the tens to hundreds of milliseconds, and they want to go pretty much below that, because in the automation world, we're talking like response times of under a millisecond sometimes. So that's what the new OPC UA FX wants to target, and they have multiple specifications for that. For one, they specify controller to controller, which is basically the first specification that they already completed, which allows you to do this here, but in a more deterministic manner that's more suited to the whole field stuff. Then they want to create the specification of controller to device, which is basically your PLC, or higher up can now talk to your drive, sensor, output, and interact with that. And one pretty interesting feature which is then coming is the device-to-device communication, which allows you to do networking across devices in a system. So basically, let's say this actuator here can talk to this actuator, or this a sensor here can talk to a drive here. Maybe this actuator here wants to know something from that, which the OPC UA device-to-device would allow you to do, which is actually pretty nice. This suite of specifications is still in process. So they only completed one specification of the OPC UA suite, which is the controller-to-controller specification, which basically implements the thing that we said, that different controllers and PLCs can talk to each other. The whole thing can then also run over a time-sensitive network to provide that certainty about when your data arrives, and also to provide a time criticality criticality, so you can rely on the stuff that you receive and you can talk to, so you don't have to basically work against a lot of latency or such stuff. As I said, it implements the multi-controller environments, and it also allows you to exchange process data. Process data is basically the stuff that communicate, the data that is communicated between devices and controllers, which is normally very little data, like we're talking tens to maybe hundreds of bytes, but not more. But we communicate that data over and over and over again in a pretty rapid manner. That allows us to control stuff in a timed manner. We know exactly when our data arrives, and we know exactly when we can send the data, and the other device, basically the device, the drive, sensor, whatever, knows when it can expect new data, which then allows it to interpolate and handle more deterministic. The controller-to-controller specification now also includes safety data exchange specifications. There is process data and there is safety data. The industry now moves more towards safety critical applications, which means basically that you have a system that can guarantee you that it can go to a safe state if it needs to. Let's say maybe you have a machine where you have to open it up to maybe do some maintenance. In the past, you had to switch off the whole machine, like there was no way around that. Now the industry is moving towards you can open the machine, but it will move more slowly maybe, and it will also guarantee you that. Like there is a whole swathe of specifications and also certifications that you have to do to achieve that, and that's also incorporated in the controller-to-controller specifications so that you can transmit this sensitive data. It has a lot to do with redundancy, and this basically then allows you to guarantee a user that he is not in danger. So that's basically what the controller-to-controller specifications does. And as I said, we now have the controller-to-controller specifications. These specifications are pretty new, like the controller-to-controller specifications was like released a year or two ago. It's insanely new. And the other device-to-device and controller-to-device, they are still in the process of being specified. Like they are not even available right now. They are something in the future, but they will probably then allow us to talk all the way and across however we want. So that's pretty nice. This is basically all about OPC UA now. The quick thing. Maybe we have some time for questions, if we have questions. Otherwise,
I utilize Modbus TCP/IP because I have 70 PLC in Merano in the city, and I have it in a VPN network. Mm-hmm. Which is the difference at the end between like Modbus TCP/IP, which is a really old, simple protocol, and OPC UA?
OPC UA kind of puts you at a higher level. OPC UA is not that concerned with, for now, how you talk to your devices. I can speak for us. We also connect to PLCs. We use field buses like Ethercat, PowerLink, and Profinet. And the whole talking to the device, that's one thing that basically the PLC talks to the drive or to the devices or I/O. OPC UA doesn't really get into that. OPC UA provides you a layer higher. So it basically abstracts that away from you and provides you an interface that you can then use to talk to those drives, basically. So normally it's implemented as you expose some PLC variables via OPC UA to maybe a parent application that then drives that, visualizes data from there, and does that. So you're basically, setting up a higher level. Okay. So that's the concept of the OPC UA. Which,
I have another question. The cloud, the server then, it must be in the same VPN network, or there's a way that, for example, the PLC and the cloud, it's in the same VPN, or there's a way to communicate over the internet?
They will probably communicate over the internet. Like OPC UA already has quite secure communication. Like you're talking certificates encryption and a lot of that. So the VPN stuff is not quite needed, but it probably would also work over VPN if you want to protect it. So yeah.
It's not needed to protect.
It's probably not needed, yes, because they are pretty secure in the encryption that they can use. Yeah.